All right. So on problem number 1, we're supposed to graph this system of inequalities. When I look at these two inequalities, there's one that jumps out at me as being the easier one to get graphed. Which one of these two, the top or the bottom, do you think I'm looking at? And I was like, I want to do that one first. It looks easier. Yes, sir. Huh?
The top.
The top one? What do you see about the top one?
It has, I forgot.
That's okay.
It's on the other side.
It's on the other side, so we got the x and the y on the other side. Any other thoughts? Zay? You like the bottom one because the y is isolated. You liked the top one for like the exact opposite reason, right? Okay. So let's look at these two. I think for the time being, I'm going to go with Zay's suggestion first, and then we'll come back and look at yours. There's nothing wrong with doing it in the reverse order, by the way. So if you like the top one better and you want to get that one graphed first, that is totally fine. I do like that the y is all by itself here. Because it reminds me of slope-intercept form, y equals mx plus b. And I know how to graph things pretty easily in y equals mx plus b form. When I'm looking at something where the y is isolated, slope-intercept form, where's the first dot I want to put down? Which one? The y-intercept. Where's the y-intercept on this one right here? -1. So here's my y-intercept. We're going to put it on the y-axis at 0, -1. There we go. Now that I got that first point plotted, what do I do from here? Make the 2 into a fraction. I make it into a fraction by doing what with it? Yep, putting a 1 on the bottom there. So it's going to become 2 over 1. And now I use that fraction. How? It tells me how to move. How am I going to move? I'm looking for words like up and down and left and right. Up, 2, right, 1. Why not left 1? Because it's a positive. So we're going to go up 2. The 2 is positive, so I'm going up. If our numerator was a negative, which way would I go? Then I would go down. When the denominator is positive, we go to the right. If you ever see a denominator that's negative, then you would go to the left. I did that the wrong way for you guys. It was my left, but it was your right. All right, so up 2 and right 1. Up 2 and right 1. Straight on till morning, till I can't do it anymore. Is that all the dots that I can put on here for this line? How do I get more? I can't go up 2 anymore on my graph. Go down 2 and still to the right 1?
No.
Why left 1? Yeah, we do everything in reverse. If you're going to go backwards, you got to do everything backwards. Down 2, left 1, down 2, left 1. Okay. And then I grab my straight edge and I just draw a straight line through it, right? Yes, sir.
It's not equal to, it's just y is less than, so use a dashed line.
Dashed line. If it had that or equal to underneath it, then I would just grab my straight edge and go straight through it. But if it doesn't have that or equal to on it, then it needs to be dashed. Okay. So I'm going to do my dashed line. It's only going to be so pretty. Am I done with this one? Can I move on to that top one finally? I do have to shade. On an inequality, I have to shade. The things that I shade indicate that it's a solution. In fact, the whole reason why I just used a dashed line right here is because any points that actually fall on that dashed line would not be solutions. If I put them into the inequality, it wouldn't work. But where I shade is supposed to work. I'm going to put two letters up here. We've got an A and a B. Am I going to shade the A side or the B side for this? The B side. Why the B side? It's a less than, so we're going to shade below. When I have my y isolated, when I have it in slope-intercept form like this, if it is a less than, I'm going to shade below. The below side on this is B. So I'm going to shade this very lightly now. First period, it shaded way too heavy. It was hard to see stuff later. There we go. If I grab any of the ordered pairs in that section that's shaded, they will work in my inequality. Now can I go and do the other inequality? Yes, now I can do the other one. So now we're going to go look at the top one. There's a lot of stuff that I like about the top one. There's one thing that I notice about it that is profoundly different than the bottom one. What's really different from the bottom one? What's not alone? Y is not alone. When I'm working with inequalities especially, I really want the y to be alone because not only does that put it into slope-intercept form for me, but that also tells me whether I'm going to be shading above or below after I get it graphed. If it's not in slope-intercept form, I don't know whether it's above or below. I would have to use a test point. But if it's in slope-intercept form, then I can use that little shortcut. So I need to get my y isolated. Oh, okay, so y is right here. That means that's not moving. Everything else that's over there on the left that's not the letter y has got to go. How do I make it go? Subtract 5x. Why are we starting with subtraction? It is a positive. And I'm also thinking about my order of operations here, PEMDAS. Whenever we are trying to isolate something, get something alone, solve for something, we're going to go backwards through the order of operations. So whenever I want to get something alone, I have to start by undoing any addition or subtraction first. And we're starting with subtracting here. Even though I see a minus, we're subtracting because the thing that I want to get rid of is a positive thing. And I want to make that cancel out. All right, so I'm going to bring down my negative 2y. Do I need to flip my inequality? Does it need to change directions? No. When I add and subtract things, it does not change. So this stays a greater than. I want to put the x part next so that it stays in slope-intercept form. Is that a positive 5x or a negative 5x? Negative 5x because we minused it, right? So I have minus 5x. On the other side, he was a positive. You're right. Is the 10 a positive or a negative? Negative. So what do I put after the minus 5x? Minus 10. Has to stay a negative. I'm bringing down what I've got right there. Is my y all alone yet? No. What do I still need to do? What's connecting the negative 2 and the y together? I like your idea because most of the time we are going to plus there. Multiplication is the thing that's connecting these two together. And so I need to break or undo that operation there. So we're going to divide, yes. I'm going to divide by negative 2. If you do it to one side, do it to the other side. So like this. Got to do it to the whole thing. I have to do it to every single term. You have to distribute with division exactly the same way you would distribute with multiplication. Do I need to flip my inequality this time? Yes. Why? We divided by a negative. So that tells me right there that I need to flip this inequality. Negative divided by negative, positive. So I'm going to have a positive 5 over 2x and a positive what? Positive 5. All right. Do I have my y isolated? Yay, I do, finally. Where's my first point? On the 5. On what? Like just like on the y-axis. So here's my y-intercept. So we're going 0, 5, because remember in my ordered pairs, the x always comes first and then the y. Where do I move from there? Up which way? Up 5 over 2. And when you say over, you want me to go which way? To the right. My denominator is a positive, so I'm going to the right. Up 5, right 2. You guys can do that on your graphs. I'm stuck, though. I can't go up 5 on mine. I run off the screen. So I'm done? I just can't graph it? Yes, I can go down 5 and left 2. Oh, I see what I did wrong before. I screwed this up in first period. Oh, well. It happens. Down 5 and left 2. Solid or dashed line? Why? Because it has the or equal to on it this time. So solid line here. Okay. I need my arrows on either end. And I'm done. Still have to shade. Am I shading above or below? I'm really confused because here it had a greater than, but over here it has, oh wait, I said flip and then I didn't flip it. It's not Monday, but it feels like a Monday. I wrote the right words and I didn't do the right thing. You guys ever do that in your work? Happens to the best of us. Doesn't mean you don't know how to math. Where am I going to shade? I have a greater than or equal to here. I have a less than or equal to here. Do I shade above or below this? I heard both words. What form does it have to be in for me to look at the inequality? It needs to be in slope-intercept form. I need the y by itself if I'm going to just look at the inequality and know above or below. Otherwise, I got to pick out a test point. Guys, put it away for me, please. So I'm going to shade below. This line is almost vertical, so I'm trying to figure out the below side. I'm only looking at the blue line here. Which side is the below side, the A or the B? B is the below side. When I'm looking at something that's close to vertical like that, I kind of like to think about it like if I was out in the rain. Where would I stand to be underneath my umbrella? I'd be over there. We are almost finished here. We still need to identify a solution. And this actually leads me to talking about one other thing that I wanted to point out. If you weren't sure which way to shade on that blue line, you're like, I don't know which side is the above side, which side is the below side. I'm really confused because we flipped our inequalities. You can always pick out a test point. If it comes back true when we substitute it in, then you shade where that point is. If it comes back false, then you don't shade where that point is. So let me give you an example. Let's look at the origin. Let's look at 0, 0. If I take 0, 0, and I put it into this top inequality right here, I put 0 in for x and for y. So I have 5, and then I put in 0. Minus 2, and then I put in 0. Greater than or equal to negative 10. What's 5 times 0? What's 2 times 0? What's 0 minus 0? So I get 0 is greater than negative 10. Greater than means that it's to the right on the number line. Is 0 to the right on the number line from negative 10? Yeah. So that means I definitely wanted to shade where 0, 0 was for the blue line. Do you think that point would work for the red inequality? No. Let's test it and see why. In my red inequality, I would put 0 in the place of y, less than 2 times 0 in the place of x, minus 1. What's 2 times 0? 0 minus 1? Negative 1. Is 0 smaller than, to the left of, negative 1? No. And we didn't have it shaded in the red, did we? That's how we know when we've got it shaded correctly. I'm still supposed to pick out a point that is a solution to the system. Can you guys give me another point that would definitely work here? 1, negative 1. Let me mark that point. And then we're going to sub it in and test. 1, negative 1, right here. So in my blue inequality, we're going to put what in the place of x? 1. Minus 2 times what goes in the place of y? Negative 1. It's greater than or equal to negative 10. What's 5 times 1? Negative 2 times negative 1. 2. 5 plus 2 is 7, bigger than negative 10. Is it to the right on the number line? Yes. So it works here. And then I go to my other inequality. What are we putting in for y? Negative 1 is less than 2 times, what are we putting in for x? 1 minus 1. What is 2 times 1? 2. 2 minus 1? 1. Is negative 1 smaller than, to the left of 1? Yes. So it worked in both of them. So 1, negative 1 is a solution. Nice work on that, guys. Let's go look at our word problem. This one should go a little bit faster than our inequalities here. It says the admission fee at a small fair is $1.50 for children and $4 for adults. All right? On a certain day, 2,200 people enter the fair and $5,050 is collected. How many children and how many adults attended? We are just going to focus today on writing the system and defining our variables. We get to pick out what we want the variables to be. We got to pick out some letters. What do you guys want to use as our variables? A and C, that works for me. What do you want A to represent? I'm sorry, what? Adults. What about the adults? How many? How many adults? So number of adults. And what are we going to let C mean then? Number of children. It's a how many question again. So number of children. Okay, now we need to write our two equations. If you weren't in the Zoom yesterday, I talked about when we are looking at a system of equations word problem, how I approach these. First thing I always do is define my variables. Next thing I always do is I'm on the lookout for two different things. Are there totals? Because if there's totals, then I'm going to write the equations one way. If there's not totals, do I have a starting or an initial amount and a rate? Because if I have a starting or initial amount and a rate, then I'm going to write those equations a different way. Read through this and tell me, do you see any totals? Do you see any total amounts here? Yes, sir.
I really can't see, but 5,000.
5,050. Yes. That is a total. It's total what?
Collected.
Total collected. And they're collecting what?
Money.
Money. Total money here. That is going to go at the end of one of my equations. It is the total, and so it's going to be equal to that. Do you guys see any other totals here? The people. How many total people? 2,200. There's our total people. Sky, you need to put it up for me there. We're not even on this page. Or, yeah, we're right here. You haven't written any of it down yet. So that's my total people. So my other equation is going to be equal to 2,200. All right, let's go look at the money one. I think money's a little bit easier to find because it's got that dollar sign in front of it. Do you guys see any other numbers in this problem that has dollar signs in front of it? $4
150.
and 150. The 150 goes with what? The children. What variable did we have that means children? C. So this is going to be 1.50 C. And what was the other thing with dollars? $4. For who? Adults. So how would I write that down? You said plus 4A. Why plus and not minus? I'm sorry, everybody was talking kind of low and my ears are only so good. Why is it a positive? It's not taking away. They're going to take all the money from the children. That sounds kind of bad, but they're going to take all the money from the children. They're going to take all the money from the adults. They're going to put it together. When we put things together in math, that means we're going to add them. All right, so there's one of our equations right there. Let's go write the other equation. You said that 2,200 represents what? How many people? And we've got two variables, right? What are the two variables that we have? A and C. What does A represent? What about the adults? How many there are. So we have something that means how many adults. Do we have something that means how many children? C. So if I take how many children and I put it together with how many adults, it gives me what? 2,200. It gives me the total people. So I'm going to take all the adults and all the children. Does it matter whether I put the A or the C first? Not with addition. Would it matter if it was subtraction? Then it would matter. My order doesn't matter with addition. My order doesn't matter with multiplication. But subtraction and division, it absolutely matters. All right. Nice work on the bell work today. We'll keep talking about word problems, and I'll show you at the end of class today where you can go if you need even more assistance with word problems, especially if you weren't in class yesterday. I want you guys to flip to page 24. Flip to page 24 for me. Yes, ma'am. Yes, restroom pass is right here. I'm sorry, I forgot to announce that at the beginning, guys. My restroom policy is go when you need to go. There will be a restroom pass clipped right here. If you need to go to the restroom, come grab the pass and go to the bathroom, come back. If you need to use the bathroom and the pass is not there, then you have to wait until the other person returns it. All right? As long as we don't have any issues with that, we will keep doing it that way. All right. So I want to kind of keep rolling with what we were doing on the bell work a little bit. We're going to solve this system by graphing. One of these two equations is in the best form for graphing. Which one is it? Top one or bottom one? I heard top one. Why top one? Y is all by itself. I love it when that Y is isolated. So where do I put my first dot here? I put it on the y-axis, -5 on the y-axis. Thank you. Got it. Y-intercept, 0, -5. And then where do I go from there? 3 over 1, so up or down 3? Up 3. Left or right 1? Why right? Because it's a positive. So up 3, right 1, until I run out of room. And then I'm done. Is that as much as I can get before I draw it in?
Yeah, no, you can do one more.
Yeah, I can get another point on there. I can go down 3 and left 1. Dashed or solid line here? Solid. Why solid? It's equal to. Nice job, Zay. My first period class got really confused by that question. They were looking at me like I had 3 heads. It's that or equal to on an inequality that means solid. So if it's just straight up equal to, it's got to be a solid line. Bottom inequality. What do I want to do to this before I graph it? Isolate it. How do I isolate it?
You could add 2y to both sides or subtract 4x.
I like the subtracting 4x, but you're absolutely right. You could add 2y to both sides. I'd like to stay consistent and leave my y's over on the left just to kind of make it easier so that as we're looking at these things, we stay very consistent. So I'm going to bring down, don't forget that sign, I'm bringing down a -2y. What do I have on the right?
So, -4x plus 6.
Y plus 6, we minused something. The 6 itself is positive. So the 6 has a plus in front of it because it was a positive 6. The 4 has a minus in front of it because we minused the 4x. What next? Add, subtract, multiply, divide. What will undo the operation that is gluing that -2 to the y? Divide. Why divide?
It's multiplication.
It's multiplication happening right here. And to undo or to break multiplication, I use division. And if you do it to one side, got to do it to the other side. I do it to just one piece on the other side. Everybody distribute. Everybody gets divided by -2. Do I need to switch anything? No. Equal signs, if you turn them around, they just stay equal signs. So what would I have? 2x minus 3. Negative divided by negative becomes a positive right here. So where do I put my first point? -3 on the y-axis. So 0, -3. And where do I go from there? I heard up to and then I got too far away from you. Up to over 1. And when you say over, you mean? Right, yes. Up to and to the right 1. Up 2 and to the right 1. Up 2 and to the right 1. Till I can't go any further. Back it up. And then grab my straight edge and draw through those points there. where is the solution? I'm sorry, you said 3 what? I still can't hardly hear you, I'm sorry.
I said 3 and 3.
3 and 3 kind of looks like it. They're real close together. This is a hard one to see. This is why I want to put all the dots on there. It is 2, 1. If you look down below, we put a blue dot and a red dot there. So here's our solution. Two, 1. And even though it was hard to see, what were you looking for on the graph? Intersection point. And this is where the 2 lines intersect. I want you to keep that in mind. We're going to look at some graphs that are further down the page now. We don't have to graph these pieces. They're already there for us. If you look at the next 3 graphs, what do you notice about the shapes in those graphs? It's got a parabola and a what? A line. We have a parabola and a line. Hey, Isa, pick a spot anywhere. We have a parabola. Parabolas also get called what type of equations? Starts with a Q. Quadratic. Make sure you put your name on there. And then, are you Gavin? Okay. Go ahead and put your name right there then too. So parabola, quadratic. Here we have a line. They also get called linear functions. What do you notice about this parabola and this line? They intersect twice. They intersect in 2 points. So what do you think that means about how many solutions this system has? It has 2 solutions. Right here would be a solution. And right here would be another solution. What about the graph just below that? 1 solution. How do you know? Only intersects in 1 point. Just right here. Last but not least, graph on the bottom. What stands out to you about the graph on the bottom? Does not intersect. The functions do not intersect. They do not touch. So what does that mean? There's no solutions. No touching means no solutions. And just last period, I came up with a really horrible math teacher dad joke that I'm totally going to run with from now on. From freshmen through seniors, I'll have issues as the semester goes on with students messing with each other and touching each other's things. And I'm always telling them, keep your hands to yourself, keep your hands to... I'm going to just start saying no solutions now. No solutions. All right. I want you guys to flip the page. We're going to do just a tiny, itty-bitty little bit here, and then we're going to call it a day. Do you guys remember when we learned the substitution method for systems? We can use it here too. When I have one of my equations where the y is isolated, I can take everything after the equal sign and I can put it in the place of the y in the other equation. Yes, you'll keep your book. So I would have 6x plus 3 equals what? X squared plus 2x plus 7. Interesting. I noticed something right now. What kind of equation am I looking at? Here's what I see. Whenever I see an equation that has exponents and the biggest exponent is a 2, I'm looking at a quadratic equation. What is the very first thing we always do with any quadratic equations? Before even our GCF, if it's an equation, set it equal to 0. Then we would look for any GCFs. And when we're looking for GCFs, what's the F in GCF stand for? Factor. Then we're going to factor this. I'd like to get it set equal to 0 today, and then we'll stop right there. How do I take this and get it equal to 0? Subtract what? 6x. Where should I put the 6x over here? Underneath the 2. What else do I need to do? Subtract 3 from both sides. Where should I put that over here? Underneath the 7. So tell me what I'm going to get then. X squared minus 4x plus 4 equals 0. All right, real quick before you guys leave, your homework over this isn't going to be due until Tuesday. We don't have school on Monday, so you have a nice long weekend. We'll finish up this lesson tomorrow. Also, on our class Canvas page, if you guys need to access anything, go to modules, go to the day that you're looking for. So like if you need more help with word problems, you would click right here, word problems, because I post videos and notes. So here's our notes from yesterday. There's a lot of extra help with the word problems. There's a video right here that goes over 5 problems that is not loading. There we go. And then down below, here's our class video and the notes. Have a good one, guys.